Welcome to Engineers ThinkWorks. This is Sharu. So in this video, we'll discuss the steps involved in designing an analog Butterworth filter. So totally there are 5 steps involved. We'll see one by one. The first step is from the given questions, we will have to determine the order of the filter, that is n. So this is calculated by using two formulas, that is under two criterias. When the given question consists of alpha s, alpha p, omega s and omega p, we will be using this formula to calculate n. But when the given formula contains lambda, epsilon, omega s and omega p, we will be using this formula to compute the order n. How to derive this lambda, epsilon and all, we will be solving in the upcoming videos. So the next step is, after we are going to substitute these values, and we will be ending up some values like n is greater than or equal to 3.33 or something like that, right? Whatever it might be, we will be rounding off that value to the next highest integer. That is, if it is 3.3, you will be rounding it as 4. If it is 2.1, you will be rounding it as 3. Like, irrespective of the values after the decimal point, we will be rounding it off to the next highest integer. So that is the next step. And coming to the third step, we will be finding the transfer function h of s for omega c is equal to 1 radian per second for the value of n. So what this transfer function will be is, h of s is the transfer function. The numerator for this transfer function is constant, that is 1. This denominator will vary based on the order we have calculated. Okay, so if the n is 1, the denominator will be s plus 1. If the n is equal to 2, the denominator will be this, and if n is equal to 3, the denominator will be this, and if n is equal to 4, the denominator will be this. So based on the n values, we will be finding the transfer function h of s. Okay, next in the fourth step, we will be calculating the value for omega c. That is, here also there is two formulas. As I mentioned earlier, when alpha p is given, we will be using this formula. When alpha p is not given, and instead if it is if epsilon is given, we will be using this formula. So generally there are two types of questions. Okay, in the first question type, you will be having alpha s, alpha p, omega s and omega p. In the second question type, you will be having lambda, epsilon, omega s and omega p. In this case, you will be using this formula, and in this case, you will be using this formula. And after calculating the value of omega c, you will be substituting that in the transfer function h of s. Wherever s is there, we will be calculating like this, s by omega c. Say for example, if omega c value is 3, I will be substituting the value of s as s by 3 in the transfer function h of s. That is this transfer function which we have calculated earlier. Okay, so these are the steps involved. So once if we get into the problem, it will be much more clear, and you can understand it more clearly. So stay tuned for the problems on this analog Butterworth filter design. Thank you.